Okay, today we introduced statistical measures, so we're going to first talk about the measures of central tendency, and then we'll also talk about measures of variation. So univariate data is data with one variable. We use these in histograms, box and whisker plots, and stem and leaf plots. We have what are called bivariate data, and this is data for two variables. We use scatter plots. Anything, you could also consider lines bivariate because we have two variables, x and y, or even our exponential graphs that we have already done prior to this. Your measures of central tendency are your average measures. The most common are the mean, median, and mode. The mean is the sum of all the values divided by the total values in the set. The median is the number in the middle. If you happen to have more than or not a number exactly in the middle, you have two numbers in the middle, what you'll do is take the mean of them, so you'll add them and divide by 2. If when you're looking for the mode, this is the value or values that appear the most in a set of data can have no mode. That occurs when there are no values listed more than once. You can have one mode or more than one mode. So if you have more than a couple numbers that are listed the same amount of times, we list both of them as the mode. So in our first example, we're going to find the mean, median, and the mode. When you're asked to do this, the first thing you want to do is put these in numerical order. So here I've already put them in order, and then from here we're going to find the mean, median, and mode. I like to find the mode first. It's the easiest one, and it's the one that occurs the most. Here we can see we have 219, so our mode is 19. Our median is the number that's right in the middle. We have 10 numbers, so if we have 10 numbers, we're going to go right in between the two middle numbers, which is 11 and 12. So you can add those and divide by 2, or know that right in the middle of 11, 12 is 11.5. And then our mean we get by adding all of those numbers, and they add to be 119, and dividing them by 10 because we have 10 numbers, so you get 11.9. We find that when these values, and especially all three values, become very close together, we get something that's symmetric, and we're going to talk about that with our standard deviation. Okay, our measures of variation, these measure how spread out or scattered a set of data is. The simplest is the range, and if you remember, the range can be found by taking the greatest number and subtracting the smallest number. Standard deviation indicates how much the data values differ from the mean. So we have this right here. This is what's known as the bell curve, and I'm going to write a lot on it, so hopefully you'll follow it as I write on it. On the bell curve, right in the middle, or we should get a bell curve, it's symmetric when the mean, the median, and the mode are all about the same value. So when they get the same value, we get something that's pretty symmetric. And from here, we talk about standard deviation. Standard deviation, sorry about that interruption. Anyway, when those line up, we get something that's symmetric. And then from here, we identify the standard deviation. The standard deviation is a number, and I'll teach you how to find that in just a minute. And that number tells us how far away we go from the mean. So standard deviation, I should tell you, we use this symbol. It's sigma, and it looks like an O with a tail, and sometimes I put an X next to it. Okay. So if you're looking for when we're using standard deviation, if we go plus 1 standard deviation, it gets you to this part on the curve, or if we go minus 1 standard deviation, it gets you right here. And then we start talking about the percentage of data that lies within 1 standard deviation. And we usually will say a plus or minus 1 standard deviation. We say that here, if you notice this 34 and this 34, they add to give you 68% of the data will lie within 1 standard deviation away from the mean. We talk about 2 standard deviations. So instead of, I'll erase this, this is 1 standard deviation. You can see that here takes us to 2. Whoops, I changed color, sorry. To 2 standard deviations, and that would not be a plus, that would be a minus 2 standard deviation, this would be a plus 2. So if we take into account all of these values, within 2 standard deviations, it's 95% of the data. Then the last one we're going to talk about is 3 standard deviations, because after that it really doesn't matter, you have all of your data. Within 3 standard deviations of the mean, it takes you all the way here. And if we add up all of those values, it gets us to 99.7% of all our values will lie within 3 standard deviations away from the mean. So unfortunately we're going to need to know these numbers or these percentages for our homework. And I'll show you how we're going to use that. So standard deviation, first of all, is found by taking the sum of the squares of each difference of a data value in the mean, then dividing that value by the number of data, and finally taking the square root of that number. I've given you a formula. Remember that this sigma stands for standard deviation, and each of these values represent the numbers in our list. So if we had 5, 8, 12, this would become a 5, this would become an 8, and that would become a 12. This x bar right here equals the mean. And then the n is the number of values that we have. So we're going to apply that formula on our next problem. The first thing it asks us to do is find the mean, because you need the mean to find the standard deviation. So to find the mean, I'm going to call it x bar. You're going to add all those values and divide by 5. So when we add them, we get 179. We divide by 5 and we get 35.8. Then, this is the process to find our standard deviation. And whether you want to just use sigma or sigma x, I don't care. We take the difference of each value and the mean and square it, and then we add all these values. So 27 minus 35.8, notice I'm getting those values from here, and we square it. The next one will be 52 minus 35.8, and I'm going to write below it. And then we'll take 18 minus 35.8 and square it. Nope, my handwriting got really sloppy. And then 41 minus 35.8 and square that. Once we have that number, we're going to take it all and divide it by 5. And then we take that number and take the square root of all of that. Now you can do this in one step in your calculator, but if you're unsure of your abilities to use parentheses, you might do it step by step like I just showed you. So when we type this all in, I did it in one step, but if you have to do multiple steps, that's okay. Then you should get roughly 11.92, and I'm going to round to the nearest hundredth, and your standard deviation is 11.92. Okay, this is how we're going to apply that knowledge. It says the time that it takes a bicycle courier to deliver a parcel to his farthest customer is normally distributed with a mean of 40 minutes and a standard deviation of 4 minutes. So if I go back to the idea of a normal curve, and this might help if you guys draw this out, our mean here is right in the middle, and our mean is at 40. If we go plus or minus 1 standard deviation, we go 4 minutes forward or 4 minutes backwards. So 4 minutes forward would put us at 44. Backwards would put us at 36. If I go 2 standard deviations away, so this was 1, plus 1, minus 1, plus 2, minus 2. I'm going to add 4 again to get to 48, subtract 4 from 36 to get 32, and then if I want to go one more, that puts us at plus 4 is at 52, and minus 4 is at 30. Remember I said that if we go 3 standard deviations away that we should be about 99.7% of our data. So question A says, what about what percent of the trips take between 36 and 44 minutes. So remember that this is 1 standard deviation away. 1 standard deviation away means 68% of the data. Okay, between 40 and 48, this you have to break up your data just a little bit. If you remember that half a standard, if you only go one in one direction, it was 34%, and then it was 13.5%, so we're going to add those to get 47.5%. And the last one says less than 32 minutes. So less than 32, this was 34%, 13.5, and that would be this right here. So this distance here was 0.15% after the 3 standard deviations, and then after 2 it was 2.35. So when we add these 2% for this one, we end up with 2.5%. Okay, I hope that will help you with your 7-1 homework. Good luck.